Yeah. Hello, hi. I'm Steve Warren. I'm Managing Director of Avolites Media. I'd like to introduce you to a product. The product is the Sapphire Media Infinity. Now, it's a particularly good day for us because this is our proudest summer, and it's one of the proudest days in that summer. One of the few other consoles of these that exist, there are only 6 in the world. The other 4 of them are in the Olympic Stadium being used tonight for the closing of the Paralympics, as it was for the opening ceremonies, closing ceremonies. And what it's being used for, it's being used for a number of things. It's being used for the audience pixels that we all saw, 70,500 mini screens all being mapped. So the system knows where all those screens are in relation to each other in 3D space. It's quite a complex task to send video out live, mapping it live in real time. We can do a number of other things, and Selvin later will tell us a little bit more about that. I think the key thing for us was, as Avolites Media, we've been in lighting for a long time. I felt very passionately over the last 10 or 12 years that we need to take the next step and bring in the other visual elements. I don't like the barriers between lighting, video, low-res video, scenic elements from LED. So what we've wanted to do is bring those elements together. And to do that, we've got involved with the technology that was being developed by a company called Immersive. We've come together and produced a system called AI. The main lead developer, Dave Green, is at the stadium running the show tonight. We'd love to have him here, but he'll be here tomorrow. And we'd like to take you through what the system's doing. Now, the system, the reason it exists is we identified that video engineers didn't have their own dedicated control surface. Systems were being run from a timeline, or they're being run from a lighting desk. Obviously, we're quite happy when they're run from lighting desks. We make lighting desks, but we realized that video engineers wanted their own control surface. So we set about to design one, spoke with video people. Dave knows a lot about video, and this is what we've produced. We feel it's the only system of its kind and has created a new market area. So our whole target will be this seamless integration of lighting and video. Okay, I'll now pass you over to Selvin and tell us a little bit about the operator's perspective.
So, okay, basically we've got an Infinity server here, and it's being controlled from Sapphire Media, which is this control surface. The first thing I'd like to say about the server is it's actually got 1080p outputs on the back. So, did I say 10? I meant 8. 10 would be amazing, but 8 is pretty impressive. So I'll rephrase. Shall I start again?
It's all fine, no, it's good.
No, okay. So we've got 8 full 1080p outputs on the back, and each one of those is actually DA'd for a preview. So that enables us to control media surfaces up to 8K, which is obviously quite impressive resolution. And the reason that the server's capable of doing that is it's mostly down to our codec, which is written from the ground up by Dave Green, who Steve mentioned. And the codec is very clever in that it's it's based on QuickTime, but it's built from the ground up with hardware acceleration involved. So it's all of the clever stuff is done on the graphics card, and there's no need to get the CPU involved, which removes a lot of bottlenecks and enables us to do such massive canvases with such smooth playback, basically.
The screens. Why do we need the screens?
Yeah, okay, so what we've got here is, this is the interface for actually giving us a 3D visualization of what's going on at all times. You can see the whole Olympic Stadium here, so you get an overview of what's going on. And this would also be the touchscreen where you would control different sets of media. On this touchscreen here, we have the whole engine, which is called the Salvation engine, and this is more to do with the deep-rooted patching of the different systems. And you can see we've got some color control there. And then on the top here, we have preview monitors. We have 8 switchable preview monitors, which are available for previewing the input and output. And it's just a great surface, a nice touchscreen. Controllable. Obviously you can run different pieces of media from these faders and control the whole system.
X, Y, Z control of the
faders? Exactly. We've got X, Y and Z control of the model, and also any mapping that we need to do from these encoders. And then we've got access to effects here, and different buttons for controlling the interface in different ways. Playback, obviously. And yeah, that's basically it.
Hi, I'm JB Toby. I'm one of the hardware designers at Avolites. Inside we have a PC-based system with 2 graphics cards, which is mounted on a shock frame. That allows this to be toured as per normal Avolites. We have full edit management, so the edit is captured from the device, but there's also a list of edit data in here, so you can actually set this server up without having to connect it to any media, either through the front screen, and you can then set up all your resolutions, so when you actually come out you don't have to fiddle around with these things. If people unplug devices normally, you will have issues with edit, which this is all built in. We have gen lock input, so if you're working with cameras and LED screens, you can gen lock the two together. We have also sync lock between servers, so we have large services with multiple servers. You want to make sure that they render at the same time, and again there's a synchronization system for that in the unit. We have SMPTE input, audio in and output, we have DMX in and output on the product.
I would like to say I think DMX is quite a key feature, because when I look at, not so much a key feature, but it sort of makes me smile that you've got servers which come from video companies and lighting products from lighting companies. And it's not surprising that when a lighting company gets involved in video, we think, well, a lot of the time when you put video installation into a bank, for example, with 50 plasmas doing whatever, you probably want some LED lighting around it. You want some ambient lighting in the building. It seems to make absolute sense to build it into the same server and be able to treat the whole thing, again, treating the thing as a whole, taking it a step forward and stop working with like separate football teams. You do that, we do this. As far as I'm concerned, it's all visual. It all goes in the same place, and our whole sort of remit has been to keep pulling it together. And in future, you'll see dedicated protocols coming that tie our lighting products to the video products. I wouldn't mind giving one example, if that's all right, JB, if I can carry on. And so the example I'd use is, for example, like a job at the games, they weren't able to rehearse. There's a lot of things that you're not able to rehearse, like the mapping projects for the opening and closings. Why? Because you've got people in shorts running around. So what are they going to do? So they build it in a 3D model, and then they're actually able to control the X, Y, and Z of the projector mapping directly from the faders. So it's a bit like old school follow spots, where you'd open up the follow spot a little bit and pull it in on the performer. So what we're showing here is a live mapping technology. Again, we feel it's totally unique. To the best of our knowledge, totally unique. What it's doing is using this camera up here. Now, many people are saying, oh, it's like a Kinect camera. It's a very expensive version of a Kinect camera. This small camera mounted on the front of the projector would normally be used for CGI, where you want to know where the camera is in relation to the object you want to remove. The way that we're using it is to mount it on the projector and then fit these infrared sensors onto the object itself. Now, an example of this, we did a show for BlackBerry that had a complete 3D set, and we took some time to then set up the mapping on that set. Now, if they wanted to move that from one city to another, it's obviously not going to be in exactly the same place. So if this was the London set, and then tomorrow the set in Cardiff is here, instead of spending 3 hours remapping all of your vertices, you let it do it, go to lunch. And I keep saying, to me, that's the key thing, is operators are working through their lunch, working late into the night, because we all know the show has to go on. That's what we do. But the more we can do to help, the better. And yeah, really pleased with this. Developers behind me smiling away.
It's happy.
It's fantastic. So really proud, really looking at introducing new technologies on an ongoing basis. As I say, like the 4 HD SDI inputs, like the camera tracking, like having a live control surface. Everything on the control surface is touchscreen, which then allows us to do other things. For example, we're doing a job in Mexico, 22 projectors in a theme park. So we're going to then have a topographical layout of the theme park on one of the touchscreens. So the operator would then be able to start interrogating different parts of the system, not by calling up a projector number, but by going to, I want to see the projector by the beach, I want to see the projector by front of main stage, front of house, I want to see the projector backstage. And things like this, I think our touring history has shown us the simpler and faster you make things, the more people like them, We've done it too long the hard way, haven't we? Yeah. So if you want to see more, avolitesmedia.com, or come and see us, always the best way. A lot of people come to see us, and we'd love to see you down at Avolites. All right, thank you very much. Bye.